Okay, we're going to go over some of these homework problems, and what we want to do is I want to go over number 3, 36, 39, and I think 47. And here in my first period class, you guys have not done that yet. My third has already looked at that, but we're going to go ahead and take a look at those. I think there was a key point that I haven't taught you yet. You guys have done your worksheet on going between z-scores and going between areas. And so you're getting pretty good at that. But there's a key point that we haven't really talked about, and that is this shifting and rescaling. Okay? So you might want a piece of paper to write down some notes on this. Otherwise, you can just kind of follow along in the discussion. But we have to talk about shifting and rescaling. Okay. Let's say that, let's suppose I give you a test, and maybe it was it was out of 40 points. Okay? The mean was 30, the median was 32, IQR was 8, standard deviation 6, minimum 12, and Q1 27. Okay. So the first question that I want to ask is, which of these items give you a measure of position? Meaning, which of these items tell you where you are on the graph or where you are in your data? What do you think? Would the mean tell you, give you a value of your data? I mean, a measure of position. Would it be a location on a histogram? Would the mean be a location of a histogram? Okay, good. So the mean is position. Would median give you a location on a histogram? Okay. All right, and then what about interquartile range? Does that give you a location on a histogram? Okay. Does it give you a location on a box plot? No, it's not a location. What is the IQR measuring? Yes, it's the range, the spread. So that actually is this next question. Which items give you a measure of spread of the data? And so IQR would fall down here. Okay. Furthermore, what about standard deviation? Would that be a measure of position or a measure of spread? Okay, good. So standard deviation would be a measure of spread. How about your minimum? Yes, that would be a position in the data. And how about Q1 and Q3 and any other points? Those would be, okay, positions. All right. So now that you understand the difference between a measure of position and a measure of spread, now let's talk about how those change and if they change. Okay, so let's take a look at this. So here's the original test. This is out of 40 points. Okay, and like I said, you can write this down. You don't have to. If you just follow along in the discussion, it's kind of an activity or an example to get the main idea. What if I decided I needed to curve the problems and I needed to give everybody 10 points? What would change? If I gave everybody 10 points, what would it do? Okay, the mean would become 40, so it would change. The median would also change. Okay, IQR. Would I add 10 to that? Why would that stay the same? I'm adding 10 to everything, so the entire thing just does what? Shifts up. So that would be like, you know, if all your data is contained here, shifting it would just take it and move it over. Okay? So that would not change. If I subtracted, it would go that way. So shifting it would just move the data. It would not change its range. Okay? All right, so that would stay the same. And standard deviation, same thing. Okay, very good. Minimum, it would change. Okay, so that became 22, and the minimum, or the Q1, became 37. So when I added things, only the what was affected. Only the measures of position were affected. Okay? In fact, y'all are kind of just special, and you're already getting this summary down here. When you add or subtract data, the measures of position also add or subtract. Okay? So that's the summary for you guys to know. Now, let's go back, and let's do this one right here. What if I doubled our score? I said, okay, I need to, those were really bad. Let me double all the scores. What would happen? That's going by a multiple factor, right? So that's like going 2 times the previous value. Okay? So let's think about this picture right here, this little picture. If this is my data and I'm doubling it, I'm rescaling it, it's kind of like a dilation. See if I can pull this right here. No? So what happens? Does the range change? Does the interquartile range change? Do all the positions change? I mean, measures of, if, probably a better way to demonstrate this would be if my graph stayed constant. Okay, so let me delete that off. Let's say that my graph stays constant. Okay, so there's my graph. See if it'll let me separate this. And let's pretend like this is my data. I want to just grab that little guy right there. No, it's going to group the whole thing. Okay, but I pretend like my graph is staying constant. My graph is staying the same. What's changed is are all of these positions changing of all of the data here? They are. They are multiplying also. So I would be saying, okay, you have a 60, so that changed. You have a 64, that changed. IQR also dilated. And so that is also now 16. Standard deviation also dilated, and so that is now 12. So what all changes when you dilate it or rescale it? Okay, very good. So when you multiply or divide both the measure of position and the spread. Okay, finally, let me just make this one last thing, and I'm not going to go through the whole sample of it. But what happens if I doubled and I added 20? If I doubled, so I did 2 times my data, and I added 20. Oh, that's perfect. Double everything, but only the position ones also added 20. Perfect. You guys got that down. Okay, great. So what that would do, this one would double and add 20. But these measures of spread would only double. Okay, very good. So now let's do these problems in the book. Okay, book problem number 3. So turn to page 123. Turn to page 123, and let's take a look at number 3. Now, if you haven't already read this book or read this problem, here's basically what it's saying. You know, you got SAT scores, you got ACT scores. And there's a relationship between them that is roughly, if you want your SAT score, multiply 40 times your ACT composite and then add 150. Okay? So what's going to happen? We have a lowest score, a Q3, a mean, and a median. These are all measures of what? What kind of measures are those things? Measures of position. Very good. So these are all positional measures. What about those? That's measures of spread. Okay, so how would I figure out my SAT lowest score if the ACT composite was 19? What would I do? Yep, 40 times 19. Do I also add the 150? Yep, and that's how you get your answer. Okay, and that's what you're going to do on every single one of these. 40 times 28 plus 150. And that will get you your median of SAT scores. Okay. But interestingly enough, how would I handle the standard deviation and the IQR? What's going to happen there? Correct. They would only times by 40. So the SAT standard deviation would be 40 times 3. Okay? The SAT IQR would be 40 times 6, which is 240. Okay, so you follow that? Okay, good. All right, now let's take a look at the book problem number 36. Okay, so turn over to book problem number 36. All right. If you have read the book, then you know what this right here means. If you have not read the book, then you don't know what it means. And let me tell you something. You have to read the book. See, there's little things right there that are in the book that I'm not telling you. I happen to now because we're going over this. But, and, you know, I have another student who's auditing this class. He made a 2 last year on the AP exam. And he said that he just kind of skimmed the book last year and just kind of did the problems and just kind of skimmed the book. He made it 2 on the exam. He said this year he's actually reading the book, and it helps so much more. And so he has a good, firm foundation of what's going on because he has gone through and he has read the problems or read the book. So it's a good book. You have to do that. All right. So here's what this notation means. This problem follows a normal model. And this number right here is the mean. And this number right here, what do you think that is? That's your standard deviation. Very good. Okay. So what cutoff value bounds the following? The highest 5% of all IQs. So these are about IQ scores. Okay, so your IQ, like, don't confuse it with IQR. We're talking like your brain's IQ, okay? Okay, so we want the highest 5%. So where is that, and what does that look like? Where am I going to shade? To the right, good. The highest 5%. Okay. So what does that mean? What do I need to find right here? Good, I need to find my z-score right there. How can I do that? I have an area. I have an area, and I need to find my z-score though. I can't use the z. Good. We're gonna, yes, the bottom 95. Good. You know how the calculator does bottom areas. If I do inverse norm, into my inverse norm, I put in an area and I get out a z-score. But I have to put in the bottom percentage. This says a top 5%. What bottom percentage am I going to do here? Okay, good. So I'm going to do the bottom 95%, and that's going to give me my z-score. And that's 1.645, okay, which I am not done yet. So that's a z-score of 1.645. Well, what's that saying? What is that z-score of 1.645 telling you? That you are what? Perfect. Very good. I am 1.645 standard deviations above the mean. That's what that's saying. So what IQ do you have if you are smarter or you have a higher IQ than 95% of people? That would be 100, which is the mean, plus 1.645 standard deviations above the mean. And that's how you get your IQ score. So if you had an IQ score of whatever that was, then you have an IQ that is greater than 95% of people. Follow? Okay, good. All right, and these actually kind of are like those area ones that we've already done, and you guys have already practiced, so it shouldn't be too far-fetched. Let's do C, the middle 80% of IQs. Okay, so if we want to do the middle 80%, we want to know, so how do I represent the middle 80%? What's here on the left? Okay, good. So 10% are lower that way, and on the right-hand side, I didn't draw it very well, but 10% are higher. And that would give me my middle 80%. Okay, good. So how do I get my Z-score right here? Okay, good. And what calculator how am I going to find the Z-score? Inverse norm of what percentage or what area? Okay, 0.10. Now I have to do it right here at this point, which has an area below it of 10%. It's always based on the area below it. So that's the area below it of 10%. And so what did that end up being? We go to 1.281. Okay. Well, if I'm smart and I know my anatomy of my normal curve, I know this one's symmetrical. It's going to be the what version of it? Positive version of it. Okay. But if you weren't quite that quick, what inverse norm area would you have used to determine this location of Z-score? Good. It's lower. 90% is lower than that, so you would have done that. All right. So what's the question? The question is, what's the cutoff? So I guess we want to know these two. We want to know these two values here. Okay. So what do we have to say about this guy right here? This means you are smarter than average, right? You're smarter than the average bear. You're a mean of 100 plus 1.281 standard deviations above, and that would give you your IQ there. Here we would do 100 and then what? Minus 1.281 standard deviations. Okay, good. And you'd get whatever that value is. I mean, you'd put it in your calculator and find that. Okay, good. Next, number 39. I love these problems. They're fun because you're like, it's just taking everything to a whole new level. You get to find the missing stuff. I know it's kind of crazy, but I like doing that kind of puzzle. Okay. So number 39 says, find the missing parameter with these given values. They give you, I wrote mu here. Of course, what does that mean? Okay, good. That means the mean of 20, and 45% is above 30. And you have and the question is, what's that mean the standard deviation is? Okay. So when I first look at that, I'm like, I have no clue how to even start. I always start with a picture so I can physically understand what is it saying. Okay, so here's how I would do this problem. I draw myself a picture, sketch a picture. You know, you just got to do that. That's your starting place. If you can't figure out what the heck's going on, draw a picture. Okay, so there's our 20. Now, 45% of the information is above 30. So what side of the, okay, so I'm going to be over here on the right. So let's say I'm here. There's 30. What's here? Correct, good. 45% of the data is above 30. So if I know that, what am I then going to be able to calculate at that point? If I know the area of that point, I should be able to calculate the Z-score. Very good. So if I know the area, then I should be able to calculate my Z-score right here at 30. So when I do that Z-score, I'm going to go inverse norm because I'm going to put in an area. What area am I going to put in? Yes, you have to put the lower bounded area which if 45% is above, then that means that 55% was below. So I'm going to do inverse norm of 0.55. Okay, good. So calculate what that is. I'm going to grab my calculator and do that. Okay. Okay, so that makes the z-score right here 0.1257. I want you to go to 4 significant digits. 4 significant. Okay, so there's the z-score right there. Okay. So now this is probably something that you had not thought about using, but you're now going to start using this equation. You remember this equation that you had to memorize? Your data minus what? Your mean divided by your standard deviation. Oh, and you know what? I mixed parameter with. Let's put our mu right there. Okay, divided by our standard deviation. Okay, so I know everything in this equation except for one item. I just fill it in and then solve. So, do I know a z-score? Yes, I do. It's 0.1257. What is the corresponding data value at that z-score? No, right here. 30, yes. So the corresponding data value at that z-score was 30. Minus the mean, which is 20, divided by the standard deviation, which I don't know. So what can I now just use plain algebra and solve for? The standard deviation. So here we go. 0.1257 equals 10 over sigma. And I skipped a step the other day, and it kind of like killed everybody. They were thinking, how'd you get that? Okay, so let me not skip it this time. So watch the algebra, and then I'm going to skip this step from now on. If I want to isolate sigma, how am I going to get it from underneath? Multiply both sides by sigma. So I got 0.1257 sigma equals 10. Now what? Divide by 0.1257. So sigma is 79.55? Okay. Okay, so I'm going to skip this step right here from now on. I'm going to go straight from here to be able to get my answer, because in essence, really what this is doing is you could just say, okay, then sigma equals 10 divided by 0.1257. You just start switching these two components. Okay, so that's kind of the short algebra thing you just know if you miss all those other steps. Okay. All right, B, same problem. B, it's the same thing, looking for the standard deviation. So I want you to try this one. Try this one on your own. See if you can't do that one. Okay. Should the z-score be negative? The z-score should be negative, yes. because I'm on the left side of my mean. Now, question, should the standard deviation ever be negative? If you do get that, a negative standard deviation, you have messed up somewhere. Why? Because the standard deviation is defined as what? What's the standard? Okay, y'all all said that all at once and I got nothing out of that. What? Okay, good. The typical distance from the mean. And can you ever be a negative distance away from something? That's like in a black hole. Negative tells you a direction, but not a value of distance. So it's kind of like the absolute value concept, you know, and your magnitude in science. Okay. Oh, oops, I put that in the wrong place. Okay, I got a standard deviation of 18.5. Okay? All right, so you're good? Okay, next one is going to kind of use the same process, but it has something different missing. Look, what's missing? Our mean is missing. We do not have the mu. Okay, so what are you going to do first to figure out what the heck's going on? Draw a picture. I always draw a picture to figure out what's going on, what's it talking about. Okay. Yeah, this is letter C. Okay, there's my mu, which I don't know. 80% is below 100. I'm going to put 100 right here. Now, I had a question in the earlier class that was this. How did I know to put 100 on the right-hand side of my mean? Okay, right there, that's getting closer because what? Okay, go. Correct. 80% is below it. How much is below the mean? 50% is below the mean, so 80% being below it means that it's got to be over here on this side, okay? Which I think is where you were going maybe, but just couldn't like put that in, conceptualize it, put that into words. Okay. Okay, so again, if I know an area, what can I get from an area? I can get a z-score, so let's go with that. Let's get all the information we know how to get. What area am I going to put in for that z-score? The norm CDF or? Okay, gotcha. Okay, the question was, how did I know to like subtract it from one and use the other side? Okay, because in A, it told us that 45% was above 30, and when I do an inverse norm, I have to use the area that is below. So I have to just make sure when I put an area into inverse norm that I'm using a below area. Okay? All right. So here I have a below area of 80%, so I'm going to put that in. And I got a z-score of 0.8416. Okay, so now what do you want to do? Should we go to our formula and fill in what we know? Okay, do I know Z? 0.8416. Do I know the data value at that Z-score? Yes, I do. What's the data value at that Z-score? 100 minus mu, which I don't know, all divided by my standard deviation, which I do know, is 5. Okay, now this is straight algebra. Now solve for mu, and you're done. Okay, so I'm not going to do that for you. Okay, this one is the same. Good. Are you feeling comfortable with this? Do we need to go through this? Do you want to do this problem, and then I'll just pop up the answer for you? Okay. So you may want to pause the recording so that you have time to do this problem, and when you're done, pop it up, and I'll just have the answer there for you. Okay, so a couple of things I want to say real quickly. Make sure that when you did your inverse norm, that you did the inverse norm of the area below, which is 90%. 10% is above, so area below is 90%. And if you calculated it all out correctly, you got a mean that was negative 2.799. Now, the question is, can a mean be negative? A mean can be negative. That's just a value. That's like average. You know, so if we were talking about the average temperature in December in Michigan, then maybe it would be negative. Okay, so the average can be negative. Its standard deviation, no. Okay, this recording's from my first period, and so here we go. Ready to go.
Hi, Abby. I love Abby Aldrich.
We do. Okay, so we're going to do book problem number 47. This one has 2 values that you don't know. This one has 2 values that you don't know. It has a mean and a standard deviation that you do not know. So let's take a look at this, and we're going to draw a picture. So if we know that 5% of babies learn to walk by age 10 months. So here's my 5%. And I know that my value at that point is 10 months. Okay. So my mean is going to be in my mean value of months. And if I know that 75% of babies learn to walk by 13 months, so where's that going to be? Over here somewhere. 75% learn to walk by 13 months. So I have those 2 amounts, and so then what can I find at those 2 values? I can find my Z-score. So go find your Z-score at those 2 values. And so put in your inverse norm of 5%. Okay, so that's going to be a Z-score of negative 1.645. And then put in do your inverse norm of 0.75. And that's a Z-score of 0.6745. Okay, so what I'm going to end up having is 2 equations and 2 unknowns, and so you're going to end up with a system. But let's talk about how this is going to work. If I want to know this value right here of at 13 months, 13 months is 0.675 standard deviations above what? Above the mean. So 13 months is the mean plus 0.6745 standard deviations. That's what that's saying, and that's how you collect that. Now over here, however, I'm going to say that 10 months, how do I get over here to 10 months? I'm going to take my mean, and subtract away how many standard deviations? So I'm going to subtract away 1.645 standard deviations. So now I have a system of equations right here with two variables, my mu and my standard deviations, and two unknowns. So you're going to use all your different whatever methods and solve that, and I'm not going to go through that algebra there, but that's a system of equations that now you know how to solve. Okay, so that's the last book problem that I want to do for you. And next we're going to kind of talk about the normal distribution problems worksheet that you got, and then your warm-up that I want you to do for the mid-chapter quiz.